now this series program, this series actually known as Fibonacci series. Okay, so in Fibonacci series, the previous two term addition value is the next term value. Okay, so 0 plus 1, so it is 1, the next value is 1, and the of 2, the previous two value is 1 and 1, so 1 plus 1 it becomes 2, and 3, previous two terms is 2 and 1, so 2 plus 1 it becomes 3, and 5, it previous two terms is 3 and 2, it's 3 plus 2 it becomes 5. Okay, so this is the Fibonacci series. So I am going to solve this Fibonacci series. Okay, you can solve this Fibonacci series by two ways. Basically there are little bit difference between this program segment, but the main common thing is I am going to declare here three variables. Okay, and before starting the loop, and the first variable is initialized the first value, and second variable is initialized with the second value, that means 1. So first variable is a, suppose, so it initialized by 0, and second variable is b, it is initialized by 1, and third variable is c. Okay, c. So you can solve this program by implementing the logic. Before starting this loop, you are going to print here in this portion, after initializing the value of a, b, you can print the value of a and b here, and then after you are going to write down the program 1. Now in this program, in the LCV, that means loop control variable I is not responsible to print the number which is actually shown here. The loop is completely responsible for this Fibonacci series case, how many times loop will execute. It is only responsible, but the value is not generated by using the LCV or loop control variable. Okay, now now if I just write or print the value of a and b before the loop, so then this time the loop will execute up to n minus 2 terms, because 2 terms is already printed before this loop, so n minus 2 terms, terms loop will execute, and loop increase by 1 value, always be. Okay, as this LCV is not related to this series value which is printed in this segment. Now if I am just print this value in this portion, then I am going to write this thing c equals to a plus b, and then after I am just printing the c here, and then I am initialize the value a equals to b and b equals to c. Okay, so in the very first time, a and b, if it is printed in this segment, then c equals to a plus b, 0 plus 1, so c becomes 1 and c is printed, so this third term is print here, and then a becomes 1 because b is 1 and b becomes 1, and then after when the loop will execute, then 1 plus 1, so c becomes 2 and c is printed, so this 2 is printed, and then after a becomes 1 and b becomes 2. Okay, then after I am just going to run the program again, then a is 1 and b is 2, so 1 plus 2 it is 3 and 3 is printed here. So in this way you can solve this. But another way, now the second method is not basically hugely differ from this from the first method. It is if you are not interested to print the value of a and b before starting the loop, then the program will start from 1 and the loop will execute up to n terms. Okay, no n minus 2 terms. Okay, and within this loop you are going to just write down that if I equals to 1, then print suppose a, and within else if I equals to 2, for you are going to print b, and else then you are going to follow the same trick, c equals to a plus b, and then print c, and c equals to a equals to b, like this, a equals to b and b equals to c, like this. Okay, so this is the little bit difference from the previous logic. Now come to the next program, series 8, and it is going to print the Fibonacci series. And for the reason I'm declare here the A with 0 and B with 1, the previous the first two terms actually, and I'm just entering the number of terms by using the buffer reader, and it is stored in the variable n, and loop will execute from I equals to 1 to n minus 2. Why n minus 2? Because before starting the loop I just already printed here A and B. Okay, as the two terms is already printed, for this reason the final value of the loop is n minus 2. Okay, so I'm just print the first two terms before starting the loop. Okay, now I'm going to run the program. Then after see what's the output actually generated, and if the right or proper output is generated, then I'm going to print the same program without using this line. It means the A and B is not printed outside the loop, it is going to print inside the loop. And how it is actually work, and how it is actually being the program being written, let's see after you run the program first. And so I'm going to run the program, enter the number of terms. So suppose number of terms is suppose 15, and the result is Fibonacci series is 0 1 1 2 3 5 8. Yes, it is the sum of the previous two terms. Okay, suppose 8, this one 8, it is the sum of the previous two terms 3 and 5. And suppose 21, so 21, it is the sum of the previous two terms 8 and 13. So Fibonacci series is generated. Now I am going to print the A and B within the loop. And how? Let's see. So you can see I'm just print the value A and B inside the loop, and as the value is not two terms of first two terms is not printed before starting the loop, and for this reason the final value of the loop will be up to n terms, and that's why I'm just written here that I is less than equals to n, not n minus 2 as just previous method, because in the previous method the A and B is printed in just starting of the loop, and that's why n minus 2. But as the value I'm not printing here before starting the loop, it is going to print within the loop, and for this reason the loop will execute up to n terms, and if the I equals to 1 then A will print it, and if I equals to 2 then B will print it, and for the rest of the other cases the previous statement will execute. Okay, let's see what's happened. I'm going to run the program, and the program asking me to enter the value of number of terms of 15 terms. Okay, so 0 1 1 2 3 5 8 6. So this is the exactly same and right Fibonacci series, okay, which is generated as early by the another method or methodology or another technique actually. So you can see by using the both the technique, by printing the first two terms before starting the loop or within the loop, you can generate the Fibonacci series.